Hi everyone, welcome to MH Math Facts. In our video today we're going to talk about multiplying fractions. So first off, let's do a couple of shorter examples. With multiplying fractions, it's actually not too bad because we can multiply straight across. We don't need to find a common denominator or anything, we can just multiply. So in this first one we have in the numerator 2 times 1, which is just 2, and in the denominator we have 3 times 5, which is 15. Now we always want to ask ourselves, can this fraction that I got as my answer be simplified? And in this case, it can't. It's as simple as it's going to get. So we'll go ahead and circle that. Now let's do the second problem. 2 times 3 is 6. 3 times 5 is 15. Can this be simplified? Yes, it can. Both of these numbers, both the numerator and the denominator, can be divided by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So we end up with 2/5. Now I want to point something out here. Notice in our original problem, we have a 3 in the numerator, and we have a 3 in the denominator. So there's a cool trick that if you have a number both in the numerator and the denominator, they're going to simplify to equal 1. So we could have gone straight from this original problem, done this simplification, and said, okay, 2 times 1 is 2, 1 times 5 is 5, and gotten the answer a little bit quicker. So that's a helpful tip for future problems. Okay, so now what do we do when we have bigger numbers? Well, we could multiply straight across like normal. That would get us the right answer, but we would end up with a lot of simplifying that we would need to do. So I'm going to show you a helpful trick to make it so that you don't have as much simplifying to do at the end. So the first thing we're going to do, we're going to factor out, we're going to find the prime factorization of each of these numbers. So we'll start with 640. That's the same as 10 times 64. 10 is 2 times 5. Both of those are prime. 64 is 8 times 8. And 8 is 2 times 4. 2 is prime, so we'll circle those. And 4 is just 2 times 2. Sweet, let's move on to our next number. Let's go with 693. So 6, 9, and 3 are all divisible by 3, so this number should also be divisible by 3. Let's see, 6 divided by 3 is 2, 9 divided by 3 is 3, 3 divided by 3 is 1. And let's see, if you add up the digits of 231, that is, let's see, 2 plus 3 is 5, plus 1 is 6, which is divisible by 3. So that's a trick to know that this number is also divisible by 3. And let's see, that would be 3 and 77. You can do a little division problem off on the side if that's helpful. Okay, 77, that's 7 times 11. Okay, this one, 99. That's 9 times 11. 11's prime. And 9, that's just 3 times 3. And then let's look at 128. Okay, so that's divisible by 2 for sure. So that would be 64. And then that's 8 times 8. So we have 2 times 4. 2 times 4 again. And then both of those 4s are 2 times 2. We'll circle all of our prime factors. Okay, so I'm going to rewrite our multiplication problem using the product of our prime factorizations. So 640, let's see, that's 1, 2, 3, 4, 5, 6, 7 2's. So 2, 2, times 2, times 2, times 2, times 2, times 2, that's 1, 2, 3, 4, 5, 6, 7. Awesome, and then times a 5. 693, that's 3 times 3 times 7 times 11. Okay, then 99 over 128, that's 3 times 3 times 11 over, let's see, 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7. That's a 2. Okay, so like we did on the last problem on the last slide, if we have the same number multiplying both the numerator and the denominator, we can cancel it out to equal 1. So we have a 2 in the numerator and a 2 in the denominator, so we can cancel those out and we just get a 1. And same with all these other 2's, as long as it matches with another one. So there's the fourth set, 5 of them, 6 of them. Let's see, this was supposed to have 7 2's. Missed one. Okay, so we're left with a bunch of 1's times 5 over there, and then just 1 in the denominator over here. Okay, we also have 3's in both the numerator and the denominator, so we can cancel those out. And also this 11. So now we have a 1 in the numerator there. So we end up with 1 times 5 times 1, which is just 5, and 7 times 1, which is just 7. So instead of having to multiply all of those big numbers out and having to try and simplify all of that down to 5/7, we were able to do a lot of canceling. We were able to simplify and then multiply, and that's going to be a lot easier. So let me know if you have any questions in the comments, and we'll see you next time.